Qualitative expressions of concentrations. The word concentrated means it is if I buy a chemical that's concentrated, like concentrated hydrochloric acid, that means that I'm buying the absolute most concentrated solution possibly makeable by a company. So when I buy concentrated hydrochloric acid, that's the strongest you can theoretically get from a company. And so the word concentrated has a specific meaning to chemists. It is the absolute most concentrated solution theoretically possible from a commercially available supplier. I mean, you can do things later, like we can make fuming sulfuric acid or fuming nitric acid by adding some stuff to the acids, but those aren't shelf stable. You make that to use it in the lab. So when you're looking at shelf stable things that can be put on a shelf and used 6 months later, concentrated solution is the most concentrated solution you can possibly purchase. Anything less concentrated than that is called dilute. And so for hydrochloric acid, concentrated HCl is about 12 molar. Anything less than 12 molar is dilute. So concentrated always means 12 molar. And because the word always means the same thing, it's a useful word. But 11 molar would be dilute. 10 molar would be dilute. 9 molar would be dilute. 8 molar would be dilute. 5 molar would be dilute. 1 molar would be dilute. 0.1 would be dilute. 0.001 would be dilute. Because you can use the word dilute for so many different situations, it's a useless word. You can use it too much. And so chemists never use the word dilute because all that it means is it's less concentrated than concentrated, which is not helpful. So when something is less concentrated than concentrated, you actually have to label the concentration quantitatively. And that can be mass percent, which is the mass of the solute divided by the mass of the solution times 100%. It can be in parts per million, mass of the solute divided by the mass of the solution times a million. It can be mass per volume percent, mass of the solute divided by milliliters of solution times 100%. It can be a volume percent, milliliters of solute divided by milliliters of solution times 100%. In chemistry, we always use molarity. These first four are how products are labeled before they're sold. In a chem lab, everything will always be labeled in molarity. Moles of solute per liters of solution is the most useful way to label something for a chemist to be used in a chemical reaction. And then molality, it's a little bit different. Moles of solute per kilogram solvent. And we're going to see that's used for colligative properties. So, mass percent. Calculate the mass percent of sodium chloride in a solution prepared by dissolving 50 grams of sodium chloride in 150 grams of water. Well, if I dissolve that salt in the water, my total mass will be 200 grams of solution. So I take my 50 grams of solute divided by 200 grams of solution. It's 25% sodium chloride by mass. Because of the 200 grams, a fourth of it is salt by mass, 25%. What is the mass of sodium carbonate needed to make 350 grams of a 12.3% aqueous solution? Well, we are just solving for the mass of the solute here. So 12.3%, to convert a percent to a decimal, we divide by 100. That's why you have that 100 here. Because remember, 50% of a pi is half of a pi is 0.5 of a pi. So 50% of an apple pie is 0.5 of an apple pie. You divide it by 100 to get the decimal. Likewise, 12.3% divided by 100 to get the decimal, 0.123 times 350 grams. I would need 43.1 grams of sodium carbonate. Saline, now we're in mass volume percent. Saline is a 0.9 mass per volume percent sodium chloride solution. What mass of sodium chloride is needed to make 50 milliliters of saline? Well, we need to make 50 milliliters, and it's 0.9% mass per volume. And mass per volume percent is grams of solute per milliliters of solution. So I have my 50 times my 0.9 divided by 100, because again, percents divide by 100 to get the decimal. And I need 0.45 grams of sodium chloride. What volume of 3% hydrogen peroxide solution will contain 10 grams of hydrogen peroxide? If you go to the pharmacy and buy hydrogen peroxide, it comes in a brown bottle. Standard solution in America is 3%. And we take our 10 grams divided by 3, the percentage, times 100. 330 milliliters of solution would be necessary to get 10 grams of pure hydrogen peroxide. What volume of soda that is 6% by volume alcohol will contain 200 milliliters of ethanol? Here again, this is volume percent. So the volume of the solute divided by the volume of solution times 100. We are looking for the volume of the solution. The soda is the solution. So we cross multiply those two to get a formula that will solve for this. And we see we need 3,300 milliliters of soda to get the 200 milliliters of ethanol here. A solution is prepared by mixing 20 milliliters of propanol with enough water to produce 400 milliliters of solution. What is the volume percent of propanol? Well, it's 20 milliliters divided by the 400 milliliters of the solution. Your milliliters of solute divided by your milliliters of solution. So the tough things on this is just to make sure you know what you're solving for. Is it a mass percent, mass volume percent, or volume percent? They're just slightly different formulas. And they word it this way because liquids are not additive. If you add 50 milliliters of water and 50 milliliters of alcohol together, you get 95 milliliters of liquid, not 100. Because when you mix two different liquids together, they pack around each other differently. That changes their packing. And so liquids do not, if they're different liquids, they don't add additively. If they're all the same liquid, like they're all water, they'll all add up. But if they're different liquids, then when they form a mixture, they pack differently with each other, and so they don't add up. And so you'll word it this way. You have 20 milliliters of propanol, and then you fill it up to a total volume of 400 milliliters. That may not be 380 milliliters of water. It may be 384 or something. And so that's just a way to word it, because liquids are not typically additive when they're different liquids. So this would be a 5% solution. And propanol in water is rubbing alcohol. So rubbing alcohol is isopropanol in water. You can buy like 91%. And it's called rubbing alcohol because if someone has a fever, you can rub it on them, and then the evaporation that occurs cools them off. And so it's useful when someone has a fever. That being said, you should take great care when someone's a small child, because when someone's a small child, they can get alcohol poisoning from that pretty easily. And so you want to avoid that with small children. Same with the alcohol hand rubs. You don't realize that as an adult, the little bit that dissolves into your skin has no effect whatsoever. But to a small child, it actually can, because kids' biochemistry are different than adults. All right, molarity. This is the one that chemists use. Chemists will always label all solutions in molarity.